after the November 2020 election, we had a lot of people who were not, forget the partisans, a lot of people that were experts who were scratching their heads. They didn't understand how things had worked out the way. Last time I was here, I dropped off a piece that was done by General Flynn about the anomalies that were observed. This is a particular approach that a mathematician from Ohio was contracted by a Senate candidate in Pennsylvania to examine the voting record because she was convinced she had won, but the vote tally disagreed with her. He looked at this at the registration and the voting record in every county in Pennsylvania. And what he found was that they all followed a pattern, exactly the same mathematical pattern. He called it the registration key. And that first illustration on page 2 shows what Bucks County, Pennsylvania looks like. The darker blue line is the population of the county. The black line is the total registrations. And there's a red line overlaying a light blue line. The red line is the votes that were tallied. The light blue line is the number of ballots that are predicted by this key. Now you apply it to one county, you have a model. Create a model, yes, it agrees with what was tallied. You take your model from that county and you apply it to every other county in the state, and you get the same result. That's an anomaly. That's what he found. Just imagine if you had a bunch of, on an opening day for the college football season, you had every game had exactly the same percentage of freshmen, sophomores, juniors, seniors, graduate students, faculty members, and folks that were not affiliated with the university show up. Exactly the same number. That's not normal. As Dr. Frank says, it's not natural. Now suppose that you had a U.S. Census reported that everybody in one county was at 10% blonde. Go to the next county, 10% of the people are blonde. Every county in the state is blonde, 10%. Not normal. In the first case, you would assume there was some incentive. You had free tickets. There was a limit on how many students could attend, and so on and so forth. The second case, the census was hacked. Absolutely no doubt. You cannot possibly get identical percentages of blonde people in the same county or throughout the state. And what he also found, he took his method to Ohio, and he found a different key worked for every county in Ohio. And in fact, he's done 18 states and only found 4 counties in the entire U.S. so far that are what you would call natural. Look on page 4. These are 2 counties in Montana. One of them I know is really remote. In fact, some guy got up at one of Dr. Frank's speeches and said, they ain't got no internet. If you look at the right-hand column, there's bold numbers R equals. And in Montana, the number is 0.863 and 0.812. That's the correlation coefficient. It determines how well 2 parameters track each other. Example I use in here is that if I'm plotting momentum versus velocity, the correlation is gonna be 1, because momentum is directly related to velocity. But if you're looking at the level on your gas gauge versus how fast you were going, they would be inversely related, and the correlation would be -1. If you have human events, like this, how many people show up on election day, you're very likely to see numbers between 0.5 and 0.8. That's what they found in Montana. If you go back and look at that number, that plot from Pennsylvania, it's 0.999. Just as tightly correlated as momentum and velocity. As I said, he did every county in Pennsylvania. Well, I haven't got the money or the time to do every county in Tennessee yet, but I've actually done 6, but I've got 5 in this report. So skip to the big picture. I'm not going to bore you with how I calculated it, but you can refer that to somebody that understands regression modeling. The first chart is for Hamilton County. Now, this is the same situation as when Dr. Frank went into Pennsylvania. The first county he does is going to model it using this 6-order polynomial regression. And then the model is going to be pretty good. Now, in this case, it's really good. Better than you would expect for a normal process. So this is the regression lines for Hamilton County. Correlation is 0.997. It all looks fairly interesting, and you notice that the voting tracks the registration. That isn't normal either. I can do this same thing just taking the turnout, and I get a correlation of about 0.92. Anything over 0.9 is not normal. But what I did was I took this key, which is on the next page. This is that 6-order polynomial plotter. I took this key and I applied it to 4 more counties. This is the same key that we had for Hamilton County. I applied it to Williamson. Now, it doesn't exactly overlie it, but it's really close. And the correlation of factor is 0.993. The same key. I can predict how many people of each age group, 83 brackets, in every county so far, to within a 0.9 correlation. So there's Williamson County. You're looking at some fairly strange registration numbers. We've got peaks that apparently exceed population, and they've somehow managed to register 96% of their people. Rutherford County, same story, same key, exactly what was used in Hamilton. Correlation is 0.994. Now all of this data is from this summer, so there's differences in how many people are registered. The turnout on here is from the Secretary of State, but if you total up the numbers on the voter rolls, there's thousands of people have been dropped. Still has this correlation. Can you imagine what it was like in November? I think I would have had a correlation of 1. Would have been perfect. Shelby County. Notice how in Shelby, you can see this, it almost looks like the blue and the white and the red line merge. predicted line is laying right on top of the actual vote. And then it starts diverging as you go younger. Dr. Frank has figured out, after doing hundreds of these, that they fill in the older vote before the younger vote. And they don't exceed the total number of people in each precinct. Certain rules apply to this algorithm. But these charts mathematically, unequivocally indicate there's an algorithm in operation. I was thinking on the way over here, what I would say if somebody asked me, does this prove that there was fraud? Not my job. I'm pointing out that somebody has tunneled into your vault, and you might want to check to see if you got withdrawal that wasn't authorized. Meigs County, correlation factor 989. Despite the assurances of vendors and state officials and certifying authorities, your system during the early voting and on election day was hacked. Have no doubt at all. And I spent several hundred hours proving it. I don't know how they did it. I suspect that since they've been perfecting this technique since 2004, that there's a variety of methods that they use. The demonstrations that I've seen online range from using power line modems to surreptitiously installed wireless modems to wires, cables that are hooked up to other machines that are hooked up to other machines that are hooked up to the internet. You don't have to be as sloppy as Georgia was in order to get hacked. Several thousand counties across the U.S. were hacked in November. You're not alone, and you didn't do anything wrong. This was the organized cartel that operated all across the country. In places where they had to do it, they hired people to stuff ballot boxes.
Madam Administrator, if I may interrupt, Mr. Van, we are 13 minutes into your presentation.
All right, well, I'm done.
Thank you very much. Appreciate it.